start the recording here. All right. So what I'll do is something similar that what I did last time, which is I'll use the built-in Python windows inside the lesson to kind of do some sandbox work here, and we can let it go however it goes. But we'll start at least with some concepts. And maybe what I'll do is I'll just share. Okay. This is the Explorer or the Chrome window. You can see that?
Yes.
All right. So we'll do the same thing that I kind of did last week for one or two of you that were here last week, which is we'll kind of just bounce around here, and we'll let it go where it goes, and you can certainly ask for us to do anything here. But when I first learned how to write in program, I won't say when I first learned how to do software, because this was, computer programming and software engineering are kind of two different things. You start with input, output, and printing things and fiddling with formats and things like that, like all of you did in the last week. But then you realize quickly you really can't do anything until your program has the capability to check something or test something or make a decision based on something. And for me, this wasn't very sophisticated. It was about what's the condition I want to check for, and based on the result of that condition, do I do something? In this class, what we've done is we've broken it out a little bit, and we start with what's called selection, which selection is simply put yes or no, A or B, left or right, red or blue, or what have you. It's really just focusing on selecting one or the other. And then in the week after this, we do what's called conditionals, where then you get to be a lot more complicated. And an example of a conditional might be, computing what the income tax would be based on checking all these different tax brackets, for example, or what the grade of an assignment might be by checking a bunch of different things. So we're going to focus really just on these kind of basic selections here. And so in lesson 1, we basically define the difference between sequential structure, which is what we've been doing so far. These are print statements, input statements, variable assignment statements, and so on, versus what's called selection. And for those of you that have done flowcharts, this type of thing will look somewhat familiar. This first circle here is basically a conditional statement of some sort. An example of that might be, is the value x equal to 0? And if it is, or if it's true, you do what's here. And if it is not, you do what's here. Okay, a good example of this would be 2 or 3 of you for your first assignment wrote some basic calculators. And you basically, inputs a couple numbers, and then you added, multiplied, divided, and multiplied the numbers and showed the results and things like that. But the 2 or 3 of you that did that, if I tried to do 10 divided by 0, I got an error message. And so this selection statement right here could be, is the operand equal to 0? And if it is, print an error message and move on. If it's not, do the divide. And so the key point here is that I'm doing only one of these 2. I'm not doing both of them. And then I move on. Okay, so this is all lesson 1 is trying to do, is trying to just get you into that concept of doing something or doing the other thing. And if you put your mindset to that as you're writing your pseudocode, that should help you. Okay, so then we go to what are called relational operators. And this can be tricky because sometimes I'll see that students will get relational operators or comparison operators, which is just me using a different word, mixed up with assignment operators. And so let's talk about this equal to right here. Let's talk about this one, and we're going to start with this one because this, frankly, is the one that I think trips people up the most. So what I'm going to take this code and I'm going to go put it somewhere else here for a minute. Oh, I did this already. Sorry. All right. Actually, let's start even sooner. So when I say x is equal to 3, what I'm doing here is I'm assigning the value 3 to the variable x. If I say if I do this, what do you think will happen? Do you think the yes gets printed?
Not immediately.
Not immediately. What do you mean by that?
I feel like you would have.
Sorry.
I feel like you would have to at least. Oh wait, no, never mind. You would have to put an input. Just kidding. Never mind. Take that back.
I think you have to have two equal signs for it to be because you can't use the assignment operator in the if.
Okay, so you're catching that I have only one equal sign here. But if I run this, it actually complains and tells me that this doesn't work and it gives me invalid syntax. This is actually really useful. Most programming languages do not do that. Most programming languages would actually assign x equal to 3. They'd actually put the value 3 into x here, and that automatically results in a true statement, a true result, so it would print yes, even if these two numbers were different. Okay, so now we fix this by putting the double equal here. And you see nothing printed when I ran, because I basically am doing what's called a comparison here between the value x and the value 3. They're not equal to each other. If I change that to a 3 and run it, it works. Okay, so this is the big difference here between a single equal and a double equal. Fortunately, Python does a pretty good job of preventing you from using one or the other. But I like to show the example, and if we have time near the end, I can bring up some code in Visual Studio and C++ and show you, what happens when that happens, which is basically one of the most common bugs that developers hit day in and day out, where they forget the double equal and they just do a single equal. Now, the other thing that this exercise was doing was, instead of using the if statement, it was just printing out the value of that comparison statement. So if I take a more simple version of what was originally in this window, I'm assigning 3 variables with values. 2 of them are the same and 1 is different. And if I do all 3 different combinations of comparing these 3 values, x to y, x to z, and y to z, I should expect to see, what would you expect to see for these 3 prints?
An error for the ones that aren't true.
Okay, so maybe it will print an error if it's not true.
No, I think that it's going to print yes. And then it's going to print no and no. Or yeah.
But there's no there's no command that says, or there's no print or link, or I'm sorry, concatenate, where it links a yes command or no command. I don't know.
Yeah. So I
Um,
think this is a great discussion, right? And if the answer is I don't know, we're going to try it in a minute, right? Because
you
we're
know-
not giving it any declaration to actually specify what to print. What is going to happen here is this, what's in the parentheses is going to get evaluated. Now the characters that I have highlighted in blue, what is the result of that Boolean expression?
That's going to be yes.
Say it, I'm sorry, I didn't hear you.
It's going to be true.
It's going to be true, right? So a Boolean expression by definition gives you a result of true or false. That's what Boolean means.
Right.
And I'm not a stickler for this. If you say yes or no, or 1 or 0, or true or false, or good or bad, I don't care what synonyms we use, right? I think synonyms are, I don't know if that's the right English term. So what's here in blue should evaluate to true. And then that's the question here is, what does the print statement do, right? And so if I say, you can actually do that in Python. You can, true and false are built in keywords, and you could tell because they colored blue as I typed them, right? If I spell true wrong, you can see it's black. It's hard to see on the screen. But if I spell true correctly, you see that it's blue. So actually, let me remove that for a second, and let's just run this. And you can see that printing true and printing false prints the words true and false. Now, if I do these statements and I run this, I get true, false, false for these 3 expressions. Okay, so a Boolean, if you print a Boolean, you will get, you will print out a true or a false.
So you don't need to actually specify the command of, hey, tell us whether this is true or false. It automatically knows that by the expression that you put in, right?
The expression gets evaluated in place. And since it's a Boolean expression, it gets evaluated to a Boolean value. And really, that's no different if you think about this. Like if you think about what I'm doing here, I'm putting an expression inside the print statement. It's not a Boolean expression this time, it's a arithmetic expression. And so it's going to add X and Y together, and it's going to print 20 in whatever format is default for that. And so it's really no different.
I thought it would have done something different. From the last video I was watching, how you guys were talking about if you add a plus sign, I guess it's only if there's a decimals, right? That it would not add up together. It'd be just followed after or something like that.
You're talking about concatenating, or however you say that?
Concatenation.
Concatenate.
Yeah, say it 5 times fast. You'll eventually, yeah. So yeah, so you guys are bringing up a really good point, right? The thing is that the double equal or the plus sign is an operator, right? And a plus sign, until you took this class, the plus sign, always meant a particular thing to you. I'm guessing. It always meant arithmetic addition, right?
Right.
Yes.
Always, right? Because that's what we all learned starting in whatever, 2nd grade or something, that a plus sign is to do an add, to do an arithmetic add, right? So
We also have it in Excel too, concatenation.
what's that?
They also have concatenation in Excel.
They do, and we can demo that real quick too if you want. But if I take A and I make that a string, and B and I make that a string, and I do the concatenation there, you see what it does is it puts the two of them together in a single string. And so the programming language is smart enough to treat the plus sign as a different operator based on what it's operating on. Does that make sense?
Yes. Question.
Yeah.
If we were to wanting to fix this issue where it's kind of stuck together, there's no space, is it possible to put a space between the brackets, or not the
Sure.
brackets, but the yeah, okay.
Yeah, sure. So
And then
what's a common way to do that would be to do this, right? Just do a concatenation of three things. So that would be pretty common. Or you can have a convention where you always have a space after the variable. Like you could put the space there, or you could put it there, or you could do what I did here. By the way, I'll show you something else, right? If you do this, if you print the two things with a comma in between them, notice that it puts a space in there by default. That's a formatting thing. And so actually line 13 and line 14 are doing two different things. And this is really subtle but important. In line 13, you're evaluating this expression. The evaluation of the expression that's in blue results in a single object, which gets printed. In line 14, we are printing two different objects. And the print statement uses the comma as what's called a delimiter. And by default, a comma will always put a space in between whatever it's printing. And so let's do this more specifically with the numbers to really show the difference, right?
Real quick, Jeff, is that in just Python or in every language will the comma do that?
It's Python specific. I'm pretty sure. I'm trying to go back in my memory of a programming language like Perl. I think it doesn't do the spaces. I think you could specify, right? In Python, you can change it to not have a space. Okay, let's look at what the difference is now between lines 12 and line 13. So here's where it really illustrates the difference, right? Because in line 12, you evaluate the expression and print a single result. In line 13, you print two different objects.
So can you not concatenate two integers next to each other? Because the system will automatically think of it as an algebraic equation.
That's right, you can't, right? So you have to do it in a different way. And a typical way would be to basically convert the two objects to a string like that.
Gotcha.
And then you'll get your 1010 like that. And as you get more advanced, you'll create a set of functions that you keep for all your programs, and where you have a different type of concatenation that can work on every data type, for example. So the key point of the lesson is about the fact that you can do this comparison and it evaluates to a true or a false. But we got a little sidetracked on some of this printing and this formatting because it ties together really well. What do you think? Questions, comments? Does it make sense?
It makes sense, and I kind of want to like try it out with inputs and sentence structures stringed into these now, like after the.
Well, that's the best way for you to learn it, frankly, right? You go back to your assignment 1 and you start to add a few more things, right? So if you ask for somebody's name, you ask for their first name and their last name, and then you print it with the last name in a comma, and then you print it the other way. That's how you learn it, right? If you try these different things, which are more or less what we were just trying to do. The muscle memory is really helpful in programming, right? It's really no different than learning a foreign language, right? You got to drill it, you got to practice it. And the good thing here is in Replit, you can't blow anything up. The worst thing that's going to happen is you crash your window and you bring up another window, right? So,
Right.
yeah, you're not gonna like, send the internet down with bad code here. So, in the original code that was in this window, there are also some other comparisons. The ability to check to see if a number is greater than another number, or a number is less than another number, or if a number is not equal to another number. Does anybody remember what the comparison is to see if two numbers are not equal?
Exclamation point, then equal.
So what do you think line 12? Will line 12 evaluate to true or false? I guess I got to show you the values.
I'd say true. Well, because it's not, yeah, true. Because yeah, x equals to 10 and z equals to 12, so it'll print true.
Right, 10 not equal to 12 evaluates to true. Sorry, I get distracted by like the dog coughing up a hairball behind me. Sorry. All right, she's okay. All right, so yeah, so exactly. This will evaluate to true since x is not equal to y. How about this one?
True.
X is less than y. What about, I'm gonna get a little bit more complicated here. What do you think that will do?
Let's say false. Or
I think it's
wait,
gonna
let's
give us
see.
an error.
Not true.
It's gonna give us an error
Why would it give an error?
because that doesn't make sense. Like it doesn't follow anything. Like
Yeah, you're right. It doesn't follow anything we've shown you yet. But let's see. It's actually legal. Okay, so maybe I jumped ahead a little bit. But if double equal is true and exclamation equal means not equal to, if double equal means is equal to, and exclamation point not equal is not, or exclamation point equal means not equal, what do you think an exclamation point by itself might mean?
Not.
So if I just read this out in English, I'm basically saying, is it not true that x is greater than y? I should say x is greater than z is what I wanted to do. Let's see what this one does. Oh, it didn't work. You guys were right. It's an error. It shouldn't be an error. I'm getting my languages mixed up. In some languages, this works, right? I think so. What I'm trying to get at, and not necessarily show the exact syntax here, is that if you have the ability to check for something to be true, you also can check for it to not be true. And as you do more and more complex logic, instead of saying is x greater than and equal to y, you might say if x is not less than y, for example. And those are the same things. But what we've shown in this lesson, and I'm going to put these guys back in the code here. Here's our original lesson here. If we run this, oh, I don't have the initialization, sorry. You can see that what we're doing is we're printing out information. Whatever's in the quotes gets printed out exactly. This \T is a tab command. And so what that does is it lines things up nicely here. You can see how things are lined up nicely. And we say, okay, 8 is not equal to 3, so that prints false. That makes sense. 8 is greater than y, so that's true. 8 is not greater than 3. 8 and 8 are equal. 3 is less than or equal to 8. And 8 is not equal to 8 would result in false. So here's kind of an example of using the various different combinations. Should we move on to the next one?
Yes.
All right. Okay. So I showed an example of this already, but what we were doing in the previous statement, in the previous code, is we were just creating an expression and we were printing out the result of that expression. That's still not making a decision, right? That's just printing, that's just doing more operations. So all that stuff we did in that previous code is just printing out stuff. But now what we want to do is we want to actually have our program add value by making a decision. And so, you know, this, I think of this particular example as a fun one because my teenage son has a 30-year-old car and there was a point in the time where the gas gauge doesn't work. And so he has to like mentally keep track of how far he's driven. But I could imagine that, you know, we could build a separate sensor that would have some code, and the code would basically at a certain point, you know, measure the tank. And when the tank's at a certain level or less, it's going to send a message out, right? And that's exactly what these two lines of code is doing. If tank is a value, let's just say the gallons, it somehow can tell the number of gallons in a gas tank. And when the value is less than 2, it's going to print a message. If the value is more than 2, then this statement, or I should say this expression, evaluates to false. If the value of tank is 10, this expression evaluates to false, which means the if statement will not execute. And so intuitively, this matches the English language. If this is true, then do something. And the way Python handles that is you have this colon here, and this colon is basically stating that the stuff after the colon is what needs to execute. All right, I want to, why isn't this in the, this is like not helpful that it's not in the replit. Let's bring up that code. I just got to take out the line numbers I got. Let's try this. Okay, so I've entered 10. You can see the message in line 3 doesn't get printed. If I enter 2, the message does not get printed. If I enter 1.999, the message gets printed. Okay, does that make sense?
Yes.
Yeah.
Pretty straightforward, I think. Now, this is what makes Python unique from other languages. Okay, so I enter a number. So your code, if you're looking at this, right, and the way that I have my code organized, along with what's actually in the message here, you might think that this statement is going to get printed when tank is less than when the value of tank is less than 2. The thing about Python is that if you have a colon, whatever's after the colon until the indentation goes away is the only thing that gets printed when that expression returns true. Because I might want to do more than one. I might want to print more than one message here. The indentation matters is the point. And Python is the only programming language where the indentation matters. I can't say only because there may be something I'm not familiar with, but the other programming languages that you'll learn, like if you learn C++ and Java and so on, you could do that, or you can do that, and it doesn't matter. And however you do it, the logic still is the same. Okay. So one of the cool things about this little applet here is that you can try it, and you can actually go back and forth inside the code, which is pretty cool. You can basically do a step-by-step and kind of watch what's happening. So that's the value of this. And when we say step through the code, what we're referring to is to do this one line at a time. And that's a really good way for you to get the sense of how the code is running. Okay, so that's your basic if statement. Now, what if we want to, well, actually, let's look at this code again. If I enter a small amount, it prints out time to get gas, but it also prints out keep driving. What if I only wanted to print out keep driving if I didn't need to get gas? And so in other words, I print out one of the messages, but not the other. How do you think I would modify this code?
You need else if.
So one way to do that is to use the else. Let's try that, make sure that works. So if I enter 1, I get one message. If I enter 3, I get the other message. Okay, so again, if we read this out, if we read out what we might write in the pseudocode, which says if the value tank is less than 2 gallons, then print time to get gas, else print keep going. Right? So the word else is intuitive in this function. And else is followed by a colon with the same indentation rules. Okay, this would be one way to do it. Another way to do it would be to actually replicate the condition in the opposite direction. Sorry. Some programming languages let you swap those. So if I enter 1, I get one message, and I enter 3, I get the other message. Which of the two methods do you think is better?
Probably else, if else.
Why do you think that?
Because then you can keep it in one block versus
You don't have to, you don't
Yeah.
have to have the, like the comparisons, like the greater than equal to,
Yeah.
or in the second if statement.
Yeah, that's right. That's right. I think so. The number of lines of code are the same. It's 4 lines of code either way. But I'm replicating a complex piece of the code, right? Line 3 and line 6. If I change one of them, I have to change the other. And whenever you have 2 lines of code where the one's dependent on the other, I guarantee in your career, you will forget to change one, but not the other. Like when you change one, you'll forget to change the other. I guarantee you'll do it, and you'll do it over and over and over and over. Because every software engineer I've ever worked with does it over and over and over, and I've done it over and over and over. And so you'll get feedback from me on your assignments whenever you're duplicating code, right? If you have the same comparison in multiple places or the same computation in multiple places, I'll say, hey, maybe there's a way for you to avoid that and only have the computation done once. And so this second block is better than this first block. And again, just like we show here, you can have more than one statement after both the if and the else, as long as you follow the indentation. And that's what we're doing right here. Somebody joined? Oh, I guess somebody's rejoining. Okay.
Sorry, I got logged out for a minute.
No problem. No problem. Okay, so we were just, so here's another example, which is basically kind of what we just did, right? We modified the gas tank example to more or less do what we did here. So you could play with this example and step it back and forth as well. All right. So now, and it sounds like you may not have gotten to this part here, but we'll spend a few minutes on it and give you a head start on this. If I want to do more than one comparison, and so let's use our gas tank example for a second, right? Our gas tank example basically said, hey, you better get gas or you don't need to get gas. Now, some of you might be the type of driver where you wait till the bitter end to get the gas. And so maybe what you need is, hey, maybe you should get gas for one comparison, and you really, really better get gas now as a second comparison. And so the way we would do that is we've got to do it in the other direction. We're going to say if tank is less than 1, we're going to say print you better get gas right now. Let's see if this works. Okay, this doesn't work because Python wants to be tricky and give you a shortcut for that. But before we change this, I want to make sure that the logic of what I wrote down here makes sense. We're basically saying if we're going to check with the more restrictive condition first with one message, and then if this evaluates to false, then we're going to execute line 5. And if line 5 evaluates to false, then we'll go down to line 7. And Python, for whatever reason, instead of typing else if, which is true in many programming languages, wants you to just do what's called elif, which is short for else if. So now if I enter 0.9 gallons, I get the red warning. If I enter something between 1 and 2, I get the second message. And if I enter something greater than 2, I get the third message. So now we're getting really sophisticated, right? And we're basically doing a kind of a string of different evaluations. What happens if oops, I'm going to copy this code and I'm going to put it here. What if I reorder my first 2 conditions? What's the behavior that I'll see in the second block of code that's different than the first block of code?
They're all gonna, well, if the first one's true, then the second one's true then too. So wouldn't they both be printed?
Yeah, so if I enter 0.5 as gallons, so let's try that here. So if I enter 0.5, the first block gets me that message. The second block, and actually here, let's just make this very obvious. We'll put a blocker in there so that we know. What happens is that line 11 evaluates to true. And once this is printed and this evaluates to true, the code jumps down past to line 17. So in some cases, you might want to print both messages. In some cases, you only want to print one message. So the second block, I'm going to put a comment here. This does not work. All right. How would I change this code to print both messages? In other words, I want to print line 22 and 24. Any ideas?
I don't know. Would you do like the greater than equal to? I don't know. I'm getting a little confused.
This is tricky. I think I always like to go just a little further than perhaps we should, just to kind of get people thinking.
Would you remove the elif, else if variable?
And do what?
Just leave it as print. So if tank is less than 2, print.
Okay, well, if I do that, you're getting close. So if I do that, it's going to print both messages.
Oh, so then so now you would put if tank less than 1 as well.
Yeah, so we're going to do this.
Right.
Okay, do you see what I did there? Note, look hard at the indentation.
Yeah, you pushed it over to be in line with the print, so it aligns with the first line 21.
Yeah, all of this, lines 22, 23, and 24 happen only if line 21 evaluates to true. And this else applies to lines 21 if. It doesn't apply to line 23 if. And so this is tricky stuff. And if you go back and look at the recording and you get a screenshot of this or whatever, there's going to be a point later in this class where this type of code you're going to start to feel pretty comfortable with. But right now, here we are in the first month, week 4 or whatever, this is tricky. And I will see submissions in the next couple of weeks of programs where you have your indentation wrong, and you will do accidentally what's in this third block when you mean to do something else, or vice versa. And so that's why I wanted to kind of go just a little tiny little bit further. I think that the most important takeaway here on this page is if you understand this first block of code, then you're in good shape for this week.
Jeff, I have a question about the indentations. So are the indentations just like links if it's underneath the connecting indentation? Because for an example, like you guys were talking about, on 23 and 24, it doesn't connect with else. Does that have to do with the indentation?
It does have to do with the indentation. Okay, so these vertical lines, kind of these faded vertical lines, are here to help you, but they're not physical. They're not part of the code. They're just here to help you. Okay, and so this if statement, if we start with this if statement, there's a colon right here, which means that any code that's below this if statement that is indented one or more spaces to the right of this if is part of that if statement. So okay, just like that. And as soon as I go back to the left, I've effectively broken that indentation. Now this else statement right here, it goes past this if, and it goes to the same leftmost position as this if. So this else is associated with this if statement, not with this if statement. This is called nested conditionals. And so for this week, really all you're doing are single conditionals. But again, it's, you know, for a few of you who are probing at the kind of what's coming up next, this is kind of useful to spend a few minutes on. Does that help, Donovan? Does that help clarify it?
Yeah, and if you actually add more indentations, like 3 or 4 or 5 more, that creates its own link and so on and so forth.
Yeah, like in other words, if I did something else, more indentation, right?
Yeah.
Else, and then I can even do another if here with more indentation, right? So yeah, you can, I mean, you could go, I could probably find, give me one sec. I'm just looking. I'm looking at some of my library of code to see if I can find an example. I'm not seeing anything. I could create something, but it will take some time. I don't know if there's actually a practical limit in the amount of indentation, but I've seen a lot of code that has, you know, 6, 7, 8 levels of indentation, and it can get pretty complex.
I have
Actually,
a question.
yeah, go ahead.
So in the second example you have, is it even possible to print the statement, "You better get gas right now"?
No, exactly. No, that's a good question.
Okay.
Because if for tank less than 1 to evaluate true, for every value of tank where tank less than 1 evaluates to true, tank less than 2 will evaluate to true, and that if statement will win, right?
Yeah, that's what I was kind of thinking.
Right, always. Yeah,
There's no way it'll always print what's in less than 2.
That's right.
And it would never be able to go to the elif one.
Yep, that's right. That's
Okay.
so that's a bug, right? That second example is a bug. It's a big bug.
And that's why pretty much indentations are important then to solve that bug.
Well, the indentation by itself this code has a bug because it's got bad logic. It has really nothing to do with the indentation.
Okay.
It's because you
Right.
had 2/1, right?
Yeah, the ordering that you're checking things is the wrong order. That's the problem with this second block of code. Yeah, good questions. So yeah, the example here is a similar type of example for you to play with here for lesson 5. So, all right, we're getting close to 8 o'clock here. I think I'll stop with the demo and see
I have a
what other
question.
questions you may have, and I can hang out for a little bit longer here.
I have a question.
Yeah, go for it.
Would the third example also be a bug too?
Well, I mean, does it work? Let's see if it works. Oops, wrong. It would help if I put the right input in. I mean, it does print both messages, right? So no, lines
not a bug.
20 through 29 work. And so I've honestly seen good implementations of both the first block of code and the third block of code. And it really depends on the logic. It depends on what you're comparing and how hard the comparisons are and so on. But I would almost always advocate your if statement should start with the most restrictive comparison and work your way outward. Or the more and so that's good logic to follow, right?
Well, both of them, it printed time to eat gas, but also printed all of the other statements too.
Versus, yeah, okay, so I see your point, right? So this is printing both messages as applicable, whereas the first prints only one or the only message, one or the only one or the other one, only one or the other one. So that's a good point.
So it's basically,
depending on the requirements, that third block of code is also wrong.
Yeah.
That's why I have this if applicable thing here. So
yeah.
Yeah, good. That's a good clarification.
Yeah, you could basically remove the if tank less than 1, it would print the same, I think, all the time, right?
If you removed this if statement, then it would just print all 4 of these statements. We'd be back to checking only if it's less than 2.
Yeah, it would be equivalent to what you have written here already.
So
I think.
So you could play with this kind of stuff in your code. You can reorder the if statements, change the conditionals, do it with or without else's, fiddle with the indentation, and with the practice, you'll get a good feeling for how it works. All right, what else? Other questions on this topic or any topics?
I have a question around the assignments or the lessons, I guess. Would you, I guess, in terms of like originality in our program, do you have any references on where we can get ideas? Like when it says build a program, like sometimes I'm just kind of stumped on what to do other than like a calculator or something. So is there a place that you would recommend, or how would you recommend getting more kind of originality when it comes to programs we should build?
Well, I mean, the ideally, if you think about it as you go through your day, there's problems that need to be solved in your day-to-day life, whether it's related to your job, your schooling, social, hobbies, finances, whatever. And like for a couple people, put tip calculators as their examples. And I don't know if it's because calculating tips is a pain when they go out to eat, or because they're the recipients of tips and they work in the food service, right? I don't know, right? So what I would recommend is, in your day-to-day life, think about the problems that you have to solve, right? Is it around managing your budget? Is it around keeping to your schedule? Is it around, keeping track of things? And hopefully that'll lead to some ideas. If not, what are the hobbies, and is there something you can organize around that? Don't fret if you can't be creative. I think figuring out the topic for these assignments should be the least important thing that you have to worry about. And so if you're stuck, then pick something, routine, converting between metric and imperial units, computing gas mileage, areas of a trapezoid, distance calculations, time calculations. Just pick that kind of stuff, because there's a million of those. And I'm not going to dock you if you are the 8th person that does, cubic meters to cubic feet, for example. So I don't want people to get wrapped around the axle because they think that they have to be more creative. Does that help?
Yes, a lot. Thank you.
Yeah. I think I got all sorts of creative stuff, and I got several duplicate assignments from people. The code was very different, but the problem statement was the same. The tip calculator is an example of that. The time to travel from point A to point B was another example that I got a couple people that did. But then I got some pretty clever ones. I had one of the students did calculated how many reps of different weights you needed to do, based on how much you bench press, which I thought that was pretty fun. So as an example of somebody that presumably was based on a hobby, right? Or maybe a job, I don't know. So was that one of you guys? I forget who did that. So yeah, so don't fret, I think, is the short answer. And if and you could use your study group to brainstorm. I can give some ideas too. If you send me a note, I can send out 3 or 4 ideas for a given assignment, and they may or may not be ones you like, but it might help you think of others.
Okay, great. Thank you.
Yeah, you bet. All right, well, I'm going to hit the stop recording on this. I do know that at least one of the students wants to